Check solution, matrix multiplication, right? So if you haven't watched lesson 1 on introduction of matrix and lesson 2 multiplication and addition of matrix, I would encourage you to go and watch those videos, right? So let's go to multiplication here. So we are saying multiplication of matrix A and B is possible if matrices are multiplicative confirmable. That is, the column of the first matrix, the number of columns should be equals to the number of rows for the second matrix. Right, so let's say we have A and B here. So you can see A is a matrix and B is also a matrix. So A will be having a certain order and B also having a certain order, and C will also having a certain order, which is the resultant here. Right, so let's say A is a R by N times N by C. So this will give us a R by C matrix here. Right, as you can see here, the number of columns for the first matrix are equal to the number of rows for the second matrix. Right, so automatically the result will be R by C order matrix, which is our matrix C will be having an order of R by C. Right, so let's look into this one. Given that A is equals to this matrix and B equals to this matrix, find AB. Right, so we need to find A times what? Times B here. So A times B, just put A in the place of A, then B in the place of B. So you can see A is a 3 by 3, then B is a 3 by 2. So you can see the number of columns here are equals to the number of columns for the first matrix are equals to the number of rows for the second matrix. So this will result in a 3 by 2 matrix. So let's multiply A times B here. So if you multiply A times B, you are going to have this. I know you are surprised to how do you end up having this result, but it's very simple. Let's see. Right, so when you are multiplying the matrices, it's row by column. So it's row by column. So you multiply the row and you also multiply its row, the elements in the row times the elements in the column here. So let's see here how we are demonstrating here. So you can see 1 times 1 here, it's 1 times 1, plus 0 times minus 3, so it's 0 times minus 3, plus 2 times 2 here. So this is the first element here. Right, then we go to this row again with the second column. So it's going to be 1 times 2, this is 1 times 2, plus 0 times 4, so it's 0 times 4. Then also have 2 times 5, so 2 times 5 here. So we continue with this on the second row again. We'll do the same thing. This second row, so this second row times the first column, and this second row times the second column here. Then we go to the third row again with the first column, third row with the second column. Right, so this will give us this matrix here. So if we simplify this matrix, we are going to have 5, 12, 7, 5, 6, 2 here. So that's our matrix here of A times B. Alright, so let's go this one. Given that this matrix times this matrix is equals to this matrix, find the values of X and Y here. Alright, so we are going to multiply this matrix times this matrix and equate to this matrix. So we do the same thing row by column. The first row will multiply with the first column here, and the first row again also multiply with the second column. First row multiply with the third column here. Right, so we do until we are done. So we are going to see that we are going to have this matrix equals to this matrix. So for equal matrix, corresponding elements are equal. So which means y plus 2 will be equals to 4. Then minus 1, you can see clear it's equals to minus 1. 9 minus x is equals to 10. Then 2y minus 1 is equals to 3 here. So you can solve the values of x and y here. So we are taking y plus 2. So you can see y plus 2 is equals to 4. Then 9 minus x is equals to 9 minus x equals to 10. Or you can take 8 minus 2x, then also equals to 10 here. Or 8 minus x is equals to 9 here. We'll produce the same answers here. Right, so you can see y is equals to 2 and x is equals to 1 here. Right, so this is how we need to do here. This was the requirements of this question. we are moving on to other concepts here. So we have the associativity law. So in the previous lesson, we noticed that a matrix addition is associative, right? So this also applies on matrix multiplication. So the associativity law is applying on 3 matrices or 3 members here. So you can see we have A, B, and C, right? So if A, B, and C are multiplicative conformable here, so we can know that A times B times C is equals to A open brackets B times C here. So we are just saying changing the position of the group in brackets result in the same answer here. So that's the associativity law. So matrix multiplication is associative for any 3 matrices, right? Then we go to the commutative law. So commutative law here, we are saying matrix multiplication is what? Is not commutative. So let's see how the commutative law works here. So we are saying if A and B are multiplicative conformable, that is, we can multiply A and what? And B, or B and what? And A here, right? So AB is not equals to what? To BA. So we are saying reversing the position of A and B does not result in the same answer. So AB is not equals to BA. So when you multiply matrix A times B, this is not equals to matrix B times A. Right, then we have the distributive law. So distributive law, we are just saying if we have 3 matrices A, then open brackets B plus C close brackets. So you can see A can be distributed on B, then A can also be distributed on C by multiplication. So we can say matrix multiplication is distributive over addition, right? So this is what we have for this lesson. See you in the next lesson. Thank you for watching the video. Please kindly share the video, and you can also add some comments on how we can improve our presentation and our video. Thank you so much.